right, guys. Hopefully in the Google Meets, I've had time to go over some more graphing of rational functions with you. But this is just a little overview of all the different kinds of end behaviors that can happen. So you don't have to graph anything on this worksheet. But I do need to review with you the sum and difference of two cubes. Remember, it was you take the cube root of each, then you square each of these terms that you just did, so a squared and b squared. And then in the middle, you multiplied a times b, but it was SOAP. It was the same sign here as here. Okay, let me try that again. From what it was here, you keep the same sign in the middle here, the opposite sign here, and the last one is always positive. So this was minus, so it's minus and then always positive. This one is the same. Cube root of each, square them, one of each. But because this one was plus, it stays plus here, and then it's minus and plus. Okay, same thing with x's and y's down here. I just wanted to talk you through one. A quick example, like m cubed minus 8 would be m minus 2, cube root of each. Then you square the m, you square the 2. In the middle, you put a 2 times an m. But the signs you have to take from here. Opposite would be plus, always positive, plus. All right. So I'm skipping numbers 1 and 2. I can go back and do them on a slide if you need me to. But I believe my notes were that I was going to do 3 for you. And I think it's an example like number 5. Does that sound right? Yes. I'm doing 3 and you're going to do 5. All right. First thing, you can find the y-intercept. We're not graphing these, so let's go back to the directions. It says find the vertical, horizontal, and oblique asymptotes. State any holes. So we actually don't have to find all of the features. We don't have to do the domain or the zeros. So if I factor the top, it factors x plus 5x plus 1 to give me a 6 in the middle. The denominator factors with a 2x and an x. And factors of 5, I can't multiply the 5 by the 2 or I'll get 10. So there's 5x and 2x would be 7x. There we go. So right away I notice this has a hole. And the x at the hole is -1. If I was doing domain, remember, I would have to say x cannot equal -5/2 or -1 before I cancel that out, okay? And it is going to have a vertical asymptote only at x equals -5/2 because this is a hole instead of a vertical asymptote. All right, then to find the hole, I reduce. So I go back and cancel this out, and now I put in the -1. And I get 4 over -2 plus 5 is 3. So the hole is at -1 4/3. And the vertical asymptote is here. The only other thing I have to do according to this worksheet is find the end behavior. And it is equal weight. I can look at this one or this one. Here it was degree 2 over degree 2. So it is y equals leading coefficient over leading coefficient, which is a 1 and a 2. So y equals 1/2 is the horizontal asymptote. Okay? So you're going to do one like that on number 5. Then I'm going to do number 4 because this is like, I don't know, is it number 6? Yes, number 6 that you have to do. All right, you factor the top, x plus 1. This is a cubic, so you're using the pattern. And then it's x squared and a 1x and a 1 but remember the sign changes here and stays the same back here. The denominator factors with an x and an x, and a 6, and a 1 to make 5. If I want a negative 5, I need a negative 6 and a positive 1. Guess what? We have a whole. All right, the whole. Okay, before we did anything, we would write down, if we were doing domain, x cannot equal negative 1 or 6. The whole is at x equals negative 1. Then we're going to be able to divide that out and put the negative 1 back in here. Negative 1 squared minus 1 times negative 1 plus 1 is 1 plus 1 plus 1, which is 3, over, we're putting the negative 1 in here, negative 1 minus 6 is a lovely negative 7. So the whole is at negative 1, negative 3/7. Okay? Now, I'm supposed to find vertical asymptote. There is a vertical asymptote here, not here because that was a whole. And then I'm supposed to find horizontal asymptote or end behavior. Well, this was a degree 3 over degree 2. So top heavy means that I have to divide. You actually could get by with synthetic division if you used this reduced fraction. I'm going to do long division because this is the original polynomial. You'll get the same answer though. So x cubed plus 0x squared plus 0x plus 1, I put all those zeros in, is being divided by x squared minus 5x plus 6. All right, x squared, x cubed. I need to multiply by an x all the way through. Gives me x cubed minus 5x squared plus 6x. Subtract. Or add the opposite. This is 0. This is 5x squared. This is a negative 6x. I can bring down the 1. Okay, to get an x squared to become a 5x squared, I do plus 5. So I have 5x squared minus 25x plus 30. Anything I do from here is actually going to be a remainder. If I distribute that, I'll have 19x minus 29. But that's a remainder because there's no way to make a squared become this. So we have y equals x plus 5 as our slant asymptote. All right, so that question is very similar to another one you have to do. And then there's one more. I think I was going to do maybe one of these, 7 and a sine 8. I can't remember, and I don't think I have it with me. I'm going to do this one. And it's very much like this one. All right, nasty factoring. So I have a 3x plus 5. And the top, the only way to factor 5 is 5 and 1. But 6x squared could be a 3 and a 2 or a 6 and a 1. Let's see. I need different signs. 3 and 2. 3 would be 15 and 2 would be 13. How about 6 and 1? I don't know how to get a 7 in the middle. Am I crazy? Oh no, that works. Duh. I'm crazy. There's 10x positive and a negative 3x would give me 7x in the middle. Oh, I should have taken the hint that this was in the denominator. So there is a whole. The whole is when 3x plus 5 equals 0, which would be x equals negative 5/3. Now, this is interesting. By the way, the domain would be x cannot equal negative 5/3. This has no vertical asymptote because this divides out. So there is vertical asymptote would be none. So basically, this is going to graph as the line 2x minus 1. Okay? And I can prove that too with synthetic or with division here in a minute, but basically it's all going to divide out. So what's left is just the line y equals 2x minus 1, except it has a hole. And that hole is a disgusting negative 5/3, and we have to plug it back in here. Is negative 10/3 minus 1, which would be 3/3. I got negative 13/3 for the hole. That's lovely. All right, if you want me to do the long division, 3x plus 5 into 6x squared plus 7x minus 5, multiply by a 2x would give me 6x squared plus 10x. Subtract, whoa, let's move half-power out of the way. Subtract would give me 0 and negative 3x. So negative 1 time, and it goes in evenly. Told you that was the end behavior because this all canceled out. So this is our slant asymptote. All right, I feel like I made us do one of these too. Okay. If you factor the top, it factors x squared minus 1, x squared plus 1. It is the difference of squares. But this one factors further, x plus 1, x minus 1. This one does not factor further, x squared plus 1. Okay? The denominator, all we can do is take out an x, and then we have an x minus 1. All right, so we do have a hole. The hole is here when x equals 1. The domain restrictions would be x cannot be 0 or 1 because of this x out front. Then we're going to divide this out. There is going to be a vertical asymptote at the remaining denominator, x equals 0. The whole of 1, when we plug a 1 back in, 1 plus 1 times 1 squared plus 1 all over 1 will be 2 times 2 over 1, or 4. The whole is at 1, 4. And we need end behavior. End behavior is going to be degree 2. It's top heavy. We need to divide, and we need to use long division. We have x squared minus 1x plus 0 in the divisor, and in here we have an x to the 4th plus 0x cubed plus 0x squared minus 1. All right, this isn't as bad as it looks, because you're just going to get a lot of remainder. X squared to become an x to the 4th is an x squared, so we get an x to the 4th minus 1x cubed. When I subtract that, I distribute the negative, and I end up with 1x cubed. So I need to multiply by a 1x and distribute it. And then I subtract one more time, or add the opposite, and end up with a 1x squared minus 1. This is nastier than I thought. And it still goes in there one time, which is 1x squared minus 1, and it goes in evenly. So we ended up with x squared plus 1x plus 1 as a parabola. That is, our end behavior is a quadratic asymptote. Now, I will tell you, you could have cheated. If you went right back up here, we ended up with, right here, an x plus 1 times an x squared plus 1 all over an x. If you had multiplied those two back together, x squared times x is x cubed, x times 1 is 1x, 1 times x squared would be an x squared plus an x, and a 1 times 1 is a 1. And then you put it all over an x. If you divide each of those terms by an x, you get x squared plus x plus 1, which is what we wound up with right over here for our end behavior. So we could have shortened it up a little bit and done a little bit less long division, but it was quadratic. All right, I think I assigned this one. I might have, and if I did, it's just like number 9. Then again, I might have just let you get it by without it. I can't remember. I don't think I put one on a test that was that complicated. All right, so